You're welcome to class. This is going to be the introduction to algebraic expression. And for those of you that went through class, you have the brain teasers there just to shake things up and know how far. I hope the mathematics didn't scare anybody. I just hope that everybody was able to be on the same page. Well, this is going to be our module one. And for today, which is actually the 10th, we're going to be dealing with the basic concept to algebraic expression. You're welcome to your journey as we begin the STEM Club mathematics training. And mind you, this is just the basic concept that we're going to be involving. From here on, we'll be moving further, we'll be graduating into different levels. And for those of you that are watching this video, this is your first time, please kindly move into um, you can just like and subscribe at the channel. That's for Gideon. Yes, just help me like and subscribe. All right. That being said, for today we're going to be treating introduction to algebraic expressions, and yeah, let's get to it. So, under module one, introduction to algebraic expressions, and what you're going to be learning in here, that's in these lessons, you're going to understand variable and algebraic expressions, things about variable. What are variables? What does it mean? All right. You're going to learn that. You're also going to learn about algebraic expressions. You know what? How to express algebraic things and put in equations like that. And then another thing is that you're going to translate what problems into algebraic expressions. Yes, you're going to learn how to translate what problems into algebraic expressions. And another thing you're going to learn here in this lesson is simplify basic algebraic expressions, which is quite easy. Very, very easy. Something that we can do. All right. So for the first part, we have it to be the variables and algebraic expression. What is a variable? What is a variable? What do we understand by a variable? If we use the word variable, what do we mean? So for a variable, so when we talk about variables, like I said, they are letter representations in mathematics. Okay, letter representations in mathematics. What do I mean? I mean, for every letter you have in the your alphabetical symbols A, B, C, D, E, F, G, H. In mathematics, they represent something. Likewise, in coding, they also represent something. So these are letter representations. All right, that's what variables are, letter representations in mathematics. And so, whenever you're applying this to your coding knowledge, per se, you're going to be coding, you're applying this to your coding knowledge, you're going to be using letters, you're going to be using symbols in your computer. All right, and these symbols are things that you're going to express. They are things that you're going to that are going to have meaning. Do you understand? So every letter in the alphabetical order, every letter have its own meaning. Every letter have its own meaning, and that's what variables are. All right. So once again, I tell you that variables are what? They are letter representation. And I say that again. They are letter representation, letters that have meaning attached to it. All right. So in our algebraic expression, we're going to be dealing with what variables what they actually stand for. Okay, that's what we're going to be dealing with in our algebraic variables and algebraic expressions. So let's get to it. Let's see what it entails. All right, so let's see what it entails. Let's see that. All right, so the first one says that we should write an algebraic expression for, it says, a number multiplied by 7 and then increased by 3. A number multiplied by 7 and increased by 3. So I'm going to be using a blackboard now. Okay, so all right, so according to the question, it says a number multiplied by 7 and then increased by 3. So let that number be x. So let us represent that number as x. Like I said, x now is our variable. Are you guessing that? X is the variable, meaning that x is representing something. X is standing for something. Do you understand? So let that number be x. It says a number multiplied by 7 and then increased by 3. Now, If we multiply x by 7, let the number be x. All right. So we say let the number be x. So if x is multiplied by 7, what we're going to have is x times 7, which is going to give us 7x. Now, just a quick one. Whenever you're multiplying a variable with a number, all right, they always come together. For instance, for those of us that are not familiar with it, if I have a times b, all right, if I have a times b, it's going to give us ab. If I have a times 5, the number comes first. It's going to give us 5a. If I have b times 3, the number comes first. It's going to give us 3b. Are you seeing that? When we multiply a variable with a number, all right, the number comes first, but they are always together. Likewise, if I multiply x and y, all right, I'm going to have what? xy. Okay, I'm going to have xy. So back to the question. The question said that a number multiplied by 7, we said that that number is to be x, right? Let that number be x. Okay, let that number be x. Now if we multiply x by 7, we're going to have 7x. All right, and then they said it is increased. It is then increased by 3. It is then increased by 3. Now in mathematics or in algebra, anytime you hear the word increase, when you hear increase, it means addition. All right, increase means what? Addition. So a number is multiplied by 7, that's giving us 7x. All right, it's giving us 7x, and then it is increased. That means we're going to add it by 3. So if I should put everything together, I'm going to have what? I'm going to have 7x and increased by 3, and that is our expression. We've actually done what? We've written an algebraic expression for the equation. All right, a number multiplied by 7 and then increased by 3. Quite easy, right? So I'm going to drop the next question. I just give you 1 minute. You can pause the video, give you 1 minute to solve it, and then you come back. All right, for the next question, it says that a number multiplied by 10 and then decreased by 7. A number multiplied by 10 and then decreased by 7. A number multiplied by 10 and then decreased by 7. All right, so let us see what you have. Let's see how you're going to solve it. Try to solve the question. All right, so if you've paused the video and you've tried solving the question, let's see what you got. They said a number multiplied by 10, right? And then decrease. So let the number be x. And then they said it is multiplied by what? 10. A number, let the number be x. Multiplied by 10 is going to give us 10x. Then it is decreased. In mathematics, decrease is going to be what? Subtraction. So if we have increase to be addition, decrease is going to be what? Subtraction. All right, so if we put all this together, we say let the number be x. Now, x is multiplied by 10, which is giving us 10x, and then it is decreased by 7. So that means 10x minus 7, and that is the expression. If you got that, well done. And for the next question, it says a number divided by 5 multiplied by 4 and decreased by 2. Now that is quite tactical, isn't it? But no, it's not hard. All right, so a number divided by 5 multiplied by 4 Let's do it together. A number divided by 5. Let the number, let the number be what? X. And so they said x is divided by 5. All right. A number divided by 5 multiplied by 4 times 4. So we're going to have x over 5 times 4. And they said is what? Decreased by 4. Right? So now remember 4 is standing on its own, which makes it a whole number. 4 here is standing on its own, which makes it a whole number. And let us just get something straight. Any whole number is have a fraction of over 1. I'm going to say that again. Every whole number have a fraction of over 1. So if I have 2 to stand on its own, in fraction form, 2 means 2 over 1. If 3 is standing on its own, in fraction form, 3 means 3 over 1. All right. If 7 is standing on its own, in fraction form, it is what? 7 over 1. Any number divided by 1 or have a fraction of over 1 is what? A whole number and is standing on its own. So if I should have 9, it means this is 9 over 1. And if I have 100 standing on its own, it means what? 100 over 1. All right. So we have a number divided by 5, multiplied by 4, and decreased by 4. Now, multiplication, if we multiply this, what we're going to have is this means over 1. X times 4 is going to give us 4x over 5 and then minus 4. So that is going to be our answer. Our final answer or our final expression is going to be 4x over 5 minus 4. We're going to be treating how we solve that later, but that is that. So I hope you're able to understand the first part that talks about expression of algebraic equations, like how we express. All right, expressing algebraic equations, how we're going to express and interpret them, and all that. All right, so let us move on to the next module. Let's move on to the next module. All right. All right, on to the next section. And here we're going to be dealing with simplification of basic algebraic expression. Simplification of basic algebraic expression. All right, so here we're going to just simplify basic algebraic expressions that we can, see. It's our normal math problems, normal things that we can easily solve and easily see. All right, so let us simplify. And the first one says 2x plus 5 plus 3x minus 2. 2x plus 5 plus 3x minus 2. Now, the first thing you want to do here is, okay, our question says what? The question says 2x plus 5 plus 3x minus 2. The first thing you want to do is collect the like terms. Okay? You're going to want to collect like terms. And when I say like terms, I mean what matches together, what goes together, what are the things that matches together. All right. Now if you check the equation very well, you can see x and x are the same, right? And 5 and minus 2 are whole numbers. 2x and 3x, they are both having x, so they are like terms. 5 and 2 are not having anything, they are just ordinary numbers, so they are whole numbers, they are like terms as well. If we put that together, we're going to have collection of like terms to be 2x plus 3x plus 5 minus 2. We have collected the like terms like this, and now we can easily simplify. When you simplify, it means that you're asked to solve and break it down to the simplest format. That's the meaning of simplify when we put it in mathematics. Now, if you're going to be dealing with things in your coding, it's the same, because you're going to be arranging letters together, arranging what matches together, and not mixing codes together. All right, so 2x plus 3x plus 5 minus 2, that is the like term. And now I can easily solve because 2x and 3x, they belong together, and 5 and 2 also belong together. So I can easily solve. All right, so if I'm going to solve now, 2x plus 3x, because they are the same and they're both carrying x, I'm going to have 5x. Then plus 5 minus 2, that is 3. And that is going to be my answer. I cannot add 3 to 5x because 3 doesn't have x. 3 is just an ordinary number that doesn't have a variable attached to it. 3 is an ordinary number that doesn't have a variable attached to it. And that's why I cannot add it together. So 5x plus 3 stays as my answer. That becomes the answer. All right, let's look at the next question. The next question says 4x plus 3y minus 7 plus 7x minus y. That is quite awesome. All right, that is quite awesome. Question says what? It says 4x plus 3y minus 7 plus 7x minus y. 4x plus 3y minus 7 plus 7x minus y. Now, what are the like terms here? Can you tell me the like terms? Of course, yes, you can see the like terms. X and X matches together, Y and Y matches together, only 7 stays on its own. So let us arrange alphabetically. We're going to have, if we arrange alphabetically, we're going to have 4x. What comes next? Plus 7x. Then we have plus 3y. What comes next? Minus y. Please, whenever you are collecting like terms, do not forget the signs behind your like terms. Do not forget the signs behind your like terms because that is what we're going to apply in our equation. Do not forget the signs behind your like terms. So we have 4x plus 7x plus 3y minus y and then minus 7. Remember, the signs behind your like terms are always very important. You can see the signs. You can see the signs. The signs are always very, very important. So we need to add them there. All right. We have so we have 4x plus 7x plus 3y minus y minus 7. Now let's solve that together. So that is going to be what? 4x plus 7x. That's going to give me what? 11x. Plus 3y minus y is going to give me 2y. And then I'm having minus 7. Minus 7 doesn't have anything, so I'm going to leave the answer like that. And if you've got any questions, you can put them down in the comment section here on YouTube, or you can put it down in the classroom, the Google Classroom, and I'll be able to answer your questions. Let's take a little brain teaser, all right? Let's see if you can do this. Give yourself 1 minute to do this. Let's see. You can just pause the video and try to do it, and let's see what comes up. All right, if you've done that, well done. Let's solve it together. We have 3y minus 2x. We have 3y minus 2x. 3y minus 2x. Now, this is the final answer. The reason is because they are not like terms. Y is different from x, so there is nothing that can happen to both of them. They are not like terms. Some people might like to rearrange it as minus 2x plus 3y. Still the same. the sign before every number standing on its own is always plus. So if you're wondering how I got the plus here, the sign behind every number standing on its own is always plus. Could be a number, it could be a variable. Doesn't mean. All right, so that's just the answer. There is nothing that can be done. Nothing can be done. All right, so having been said, let's move on to the next segment. Now, the next section is talking about translating, all right, translation of algebraic forms. You understand? So we're going to translate things into translate word problems into algebraic expressions. So we translate things into algebraic forms. Now, the question says translate into algebraic form and simplify. Okay, it said translate into algebraic form and simplify. All right, so the question here is 3 times a number. I'm just going to take my pen here. It said 3 times a number. Let the number be x. So they said 3 times the number, which means 3 times that number minus twice the same number minus 2 times that same number. Are you seeing that? It says 3 times a number. Let the number be x. We don't know the number. And that's one thing with algebra. You just set up variables. All right. You set up things, and those letters you're using are representations. Those letters you're using are representations. So we do not know the number. And that's why we're saying let the number be x. So it says 3 times the number. That's 3 times x minus twice the same number. That means minus 2 times the same number. So what we're going to have here will be 3x minus 2x. And that's our final answer. 3x minus 2x. I'm not really going to go deep into this so that you can be able to go through your exercises and walk through the mathematical problems, the basic concepts that are there. They're quite easy questions, easy things that you can easily pass. All right, because this is just the beginning stage. All right, so here it says 5 is added to a number and then subtracted by 2. What is that number? All right. Five is added to a number. Let the number be x. Let the number be x. So 5 is added to x and then is subtracted by 2. And they're asking, what is that number? First of all, I'm going to collect like terms. And if I should collect like terms, I'm going to say that since they didn't tell me what it is equal to, that means this is equal to 0. They didn't tell me what is equal to. They just said that 5 is added to a number and is subtracted by 2. So I'm going to collect like terms. It means x will stay on its own. 5. Remember I told you the sign behind every number standing on its own is plus. So x plus 5 minus 2 equals 0. And if we should solve this, we're going to have x plus 3 equals 0. Now, how do we make x stand on its own? To make x stand on its own, we have to move 3 to this other side. There are 2 ways to do it, okay, so that x can stand on its own. To make x stand on its own, we have to move 3 to the other side. And that means taking 3 to the other side means x will be equals to 0. Now, whenever a number is jumping or moving from one side to the other side of an equation, Look at this equality sign. Look at this equality sign. As long as the number passes the equality sign, the sign it had before will change. So if it was plus, it means that it will change to minus. So it becomes minus 3. And x will be equals to minus 3. So what if I have something like this? X plus 2 equals to 1. And I want to make x the subject. I just want x to stand on its own. So I have to move this guy here, isn't it? So it becomes x equals 1. Because it's plus that is there, as long as it is crossing the equality sign, you change to minus 2. What if I had x minus 4 equals to 0? Now, it means I need to move minus 4 to the other side. Because it's minus that is there, x will be equals to what? Plus 4, which is just ordinary what? 4. Are you seeing that? So as long as it is crossing the equality sign, what happens? The sign changes. We used to call it cross border. So when it crosses the border, the sign will change. Okay. So how else can we deal with it? We have x plus 3 equals to 0. Another way is by doing the opposite. What is the opposite of plus 3? The opposite of plus 3 is minus 3, right? So we apply it to both sides of the equation. This becomes x plus 3 minus 3 equals to 0 minus 3. And when you do that, x plus 3 minus 3 equals 0 minus 3. Plus 3 minus 3 is 0. So we have x plus 0 equals to minus 3. And x plus 0 is still x. And x is equals to minus 3. So whichever way you like, the first method was you move 3 plus 3 to this other side. And the sign changes and it becomes minus. Or you subtract with the opposite on both sides of the equation. So it depends on which one you want to choose. Now, don't rush the lesson. Go back again, watch it again, review it again, so that you can be able to digest and understand the basic concepts of algebra. Remember, this is just your first attempt. All right, so that is module 1. And you have exercises. There are exercises in the file that will be presented in the Google Classrooms. So when you just get there, you click on the file, you do your exercises, and the system will grade you. Please, if you're yet to like and subscribe, I would really appreciate that. Thank you. Until next time.